Okay, we'll get started in about a minute.
Hello.
Morning.
Morning.
All right, here we go. I got to be quieter than normal. I'm at school right now, and the ninth graders are taking their PSAT test, so I have to be a little bit quiet. There's somebody testing right next to me.
Okay.
Um, what did I want to start? Oh, yes. Um, so if you are live, that means you're probably already took your test on a Friday, and I'm just going to call out the people who have not received a test from. So Elijah, Kira, Matt, Malachi, Lily, Keegan, Nick, Riley, Ace, Ben, and Noah. I have not yet got your test. Now, as I said, if you're taking it today, then today's technically Monday, that's fine. But if you think that you took your test and you forgot to turn it in, so make sure that gets turned in. I will have if you've turned it in, except for let's see, Jameson turned his in yesterday. Did not grade Jameson's, but everyone else it's already graded in the grade book. All right, so here we go. Here's the calendar. Um, the reason why it says review tomorrow after only one day is because I have to give the PSAT test to the 10th graders tomorrow. So I will not be teaching a class tomorrow. There will be no video. I will post a review slide on what we do today. It'll just be a quick worksheet, nothing much, 10 minutes worth of work. So do the review sheet, but no formal class for tomorrow. We'll pick back up on Thursday, and you can kind of see how this rolls. After this week, remember we're in May, so there's your first 2 weeks of May. We're going to get through chapter 12. We'll just do a little bit of pre-algebra prep for next year, about 4 classes of that, and then we jump right into semester. That the week after this last week that I'm showing right here is the week before semester finals. So that Wednesday, Thursday, and Friday I always use for semester final review. One chapter per day. So we'll do that, and then that 4th week is our last week of school. We're almost there. Here's your homework for tonight. Number 10, it says to make a broken line graph. A broken line graph is a line graph. It's just another word for line graph. I'm not sure why they don't introduce that word and then all of a sudden they say, hey, do a broken line graph. It's just a line graph. So it's page 406, 407, written exercises 1 through 8, all and 10. I can't remember how many graphs are going to have you make. It's not, every one of these is not a graph. Most of these are questions about a graph. All right, so this entire chapter, chapter 12, the last chapter of our book, deals with graphs and plots, graphs and plots. Now, we finished up chapter 11 by doing one graph, a graph of a linear equation. We'll be graphing any more equations this year. We'll be graphing data. And the reason why we graph data is so that we can have a visual interpretation to allow us to answer questions about that data. We're going to see a bunch of graphs and plots this chapter. We're going to start off with the easiest one of them all. So it's entitled Picturing Numerical Data. And the way I typically introduce this to you is say, to gather data about you. If we were in class, I'd probably go around, ask 10 of you how many sisters you have, write those numbers on the board. That is the process of gathering data. I mean, you've probably seen this, either in a classroom or maybe even outside. Sometimes you go to a mall, they ask you questions. about certain things. They are gathering data. Now, the purpose of gathering data is so that they can answer questions about something. When you gather data, it's just a bunch of numbers or a bunch of answers. It doesn't really tell you any solution or any answer to your ultimate question. It's just numbers and answers. The process of arranging that data into some form that you can answer the question is what this chapter is about. All right, so let's write down a couple definitions. The first one is data. Data is both a plural and a singular word. It's like deer, right? 1 deer, 20 deer. You can have 1 data point, you can have 10 data points. So data is plural as well too. So this is numerical information about a subject. Now I have a bone to pick with the writers of this book, because data can also be non-numerical as well too. If I ask you what your favorite color is not a number, but I am gathering data about what what color you like. Next year, I'm not sure if we do any non-numerical data. I can't recall for this chapter, but absolutely from 8th grade onward, you deal with non-numerical data frequently as well too. Non-numerical data could even look like numerical data. For instance, sports analogy here: quarterbacks in the NFL only get certain numbers for their jerseys. For instance, they can't have number 99 as their jersey type thing. So if we took a poll of jersey numbers, we would be gathering numerical data, but the numbers wouldn't be something you'd want to do math with, right? So even non-numerical data can sometimes look like numerical data. Numerical data would be something like, hey, how old are you? How tall are you? That's numerical data. All right, plural for data is data. Now, some people say data. That's perfectly fine as well too. The reason why we gather data is to answer questions. And how do we answer those questions? Is we look at the data. Now, no one, including mathematicians, no one likes to look at just a whole bunch of 10,000 numbers next to each other. So we take those 10,000 data points and we graph them. We have lots of options for graphing. This chapter explores all those options, but we graph that data, and it turns out that when we graph the data, we more easily come to conclusions. Why? Because the pattern of the data emerges when you make a picture of it. All right, so here's some data right here. This is not many data points at all. Looks like it's car sales, and it looks like for decades, for the decade of the 20, 30, 40, 50, all the way up to the 80s, there are the number of cars that are sold. Now, granted, you can look at those data and picture what's going on here, but a better way of doing this, instead of just looking at the table, the raw numbers, right? That's the data itself, is to make a graph of it. This is the type of graph we'll be making today. And you can notice almost instantaneously a picture emerges, pun intended, a picture emerges of what's happening with the data. It looks like the data is growing all the way up to the 1950s, and then it kind of levels off. So within 5 seconds of looking at that graph, instead of looking at the table, you can conclude that car sales have kind of flattened off after their rise. Now, there's explanation for that. Cars really came about during the 20th century, the 1900s. And at some point, everyone had cars, and that's why the number of cars kind of sold basically levels out. Now, as population increases, those numbers can increase as well too. All right, so there's your quick and easy example of why you would want to. Now, a lot of people would argue and say, well, look at the table. You can see that from the numbers. And I agree. But remember, I'm only giving you a few data points here. Imagine, for instance, news coming out right now talking about the census. Imagine when there's 300 million. There are more than 300 million people in the United States. 300 million data points. You do not want to be looking at that table. All right, here's another graph. We'll be doing this one as well too. This is a graph that presents the data instead of using bars, instead it uses a line. It presents the same amount of data. You can get the same conclusions from it. Some people like the bar graph. Some people like the line graph. It's kind of your choice as the person who makes the graph of which type of graph that you use. All right, also I want you to think about this. When we gather data, how old are you, how tall are you, how much do you weigh, that sort of thing, those numbers are all positive. Occasionally you can get some negative numbers, but mostly you get positive numbers. And that is why we generally only use quadrant 1 of the coordinate plane when we do our graphs. Now, you can use the whole coordinate plane if you'd like. Sometimes you do have to use the quadrant. Let me use my pen here. Sometimes you have to use this quadrant right here. This is called quadrant 4 because some of your data points will be negative. But for the most part, data comes with positive, as you're talking about real world things. Data all lives in quadrant 1. So what do they do when they make their graph? If you notice, there's a coordinate plane right here. Oops, there's a coordinate plane, except they just leave off the other 3 quadrants. So if you were to draw the coordinate plane, well, there's the coordinate plane. But if all the data lives in quadrant 1, why make the other 3 quadrants? Okay, so write this down in your notes, please. The first type of graph we're going to be doing is the bar graph, So the bar graph, well, it uses bars. Now, most people would say those look like red rectangles, and I agree. But in math terms, we call those bars. When you get to higher level grades, we learn they're not called bars either. They're called BIN, bins. But for right now, bars are perfectly fine. So we call that a bar graph. And the graph, the height of the bar, indicates the value of the data for that specific category. So for instance, for the 1980s, it looks like the bar goes all the way up to the 8. And if we read the label on the y coordinate or y axis there, it says millions of cars. So that would be 8 million cars sold. All right, a couple things I want to point out with bar graphs. First and foremost is that there will be a title on your graph. You don't want to have a graph or a plot or something like that, and for the reader not have any indicator of what it even means. So immediately, as soon as I read that title, I know we're dealing with number. Because remember, you're not going to hand them the data and the graph. You're going to hand them one or the other, the graph or the data. So if you hand them the graph, and this is typically if you're reading something, whether it be language arts or science or math, they don't typically give you both the data and the table. They generally just give you the graph. So titles are important. The other parts of it, well, obviously the bars. Remember the bars, the vertical height of them indicate the actual data value for that category. And then you have your X and your Y axis. And notice that the Y axis is labeled. I mean, there's numbers for each, but the Y axis is actually labeled because 2, 4, 6, 8, 10, 12, you kind of lose something in the meaning there. So obviously there weren't only 8 cars sold in 1980, and that's why it says millions of cars. The x-axis, well, this is kind of fuzzy now. Notice we probably should put years or maybe decades more precisely there. But for the most part, labels, sometimes they'll leave off a label if it's easily understood what it means. And for most people, if they saw those numbers, they would probably immediately conclude that those were decades or time. If you think any confusion could occur, then make sure you put a label. All right, that's your bar graph. So guess what we're going to do today? We are going to make bar graphs. All right, any questions on this? Jasmine, you ever made a bar graph before? How about you, Vea?
Yeah, I have made a bar graph before.
And you should. The chapter starts off with just bar graphs, but you should have made a bar graph before 7th grade. All right, a couple of quick notes about bar graphs. If you look at the bar itself, the red rectangle there, notice they are all the same width. One isn't skinny, one isn't fat. They're all the same width. So all the bars will be the same width. Notice between the red rectangles, the bars, there's a space. And why do we have a space there? Well, you're going to learn later when we do a different type of graph that there's no spaces for that particular type of graph. But for bar graphs, we do put spaces between the bins. How much space? It's entirely up to you. So there's spaces between the bars and labels, as I've already mentioned. Labels are important simply because you just have a bar graph with no labels. No one's going to understand what the heck it means. All right, so those are just some quick notes. The last one, this is the most important one. I'm going to go back to the graph. Units must be evenly spaced. If you notice the X and the Y axis, notice first and foremost, look at the Y axis. As the tick marks go vertically, 2, 4, 6, 8, 10, 12, notice I don't spread those tick marks out. So they're evenly spaced. Secondly, the numbers go up by the same thing. I don't start going by 2s and then switch to go by 5s. Now, if we look at the horizontal axis, the x-axis, notice we're not going by 2s, we're going by 10s. And that's perfectly fine. You don't have to go for both your vertical and your horizontal by the same number. It's entirely up to you what you go by. Now, since the data was given to me in decades, it wouldn't make sense to go by 2s because I don't have data for that, but I do have data for the 20s, 30s, 40s, 50s, 60s, 70s, 80s. The vertical axis is generally the one that you will have to make up yourself. Like you'll have to look at the data and determine, what do I want to go by? Do I want to go by 1s? Do I want to go by 2s, 5s, 10s, 100, 500, something like that? Okay, so those are the quick notes. The second type of graph we're going
Wait,
to...
can you go back to the quick notes?
Sure. Okay, ready?
Almost. Sorry. Okay, I'm ready.
Okay, so the second type of graph and we'll be doing today is called a line graph. Now, a line graph and a bar graph are really close together. In fact, the only difference between a line graph and a bar graph is one uses bars, one uses lines, but how you make the graph is exactly the same. So a line graph, here's an example of it. Of the same graph, by the way, notice I'm still going by decades on the x-axis. I'm still going by 2 on the y-axis. But instead of having bars, rectangles, I got a line. Now, just so you know, I can turn this into a bar graph very easy, right? If I just make a bar right where the data point is, I can turn this into a bar graph almost immediately just by putting bars where those dots are. So there is a picture. Well, I didn't finish it, but there's your picture of your bar graph and line graph. As I said, there is really no difference between a bar graph and a line graph, except one uses lines and one uses bars. All right. Now, why would you pick a line graph over a bar graph? That's probably the best question. So for some people, they tend to visualize things better with bars, and some people visualize things better with lines. I would say if you're trying to show how quickly something is changing, a lot of times a line graph illustrates that better than a bar graph. A bar graph also takes up a whole lot of space. So if you're trying to put more information in there, for instance, something called a double line graph or a double bar graph, sometimes you might want to use one or the other. I think 8th grade is when you have to do double bar graphs and double line graphs. You've probably seen double line graphs before where they have a graph like this and there's an extra line for an extra data, like they want to compare data sets. So maybe there's another line and it's in blue and it's not number of cars, number of, I don't know, horses sold. So I don't know how many horses were sold, but let's say it went up and down and up and down, something like that. So, and then none of them were sold and then more of them were sold. So there's an indicator of a double line graph. And so what I generally say is generally use line graphs for is when I'm doing a double line graph or something like that. But tonight for homework, they're going to ask you to do both line graphs.
So why would you have double? Like, I know, like...
So if we wanted to compare the number of cars sold versus the number of horses sold, right, you wouldn't want to have 2 separate graphs. You would put both data sets on one graph, and then you could immediately compare. For instance, I just erased it, but let's see if I can put it back. Can I put it back? Yeah, there we go. So for instance, in 1950, if that literally was in blue, the number of horses sold, you can see that there was way more cars than there were horses sold. Does that make sense?
Yeah, that makes sense. Thank you.
Okay. All right, line graphs. It's still going to have the same thing. The only difference here is that instead of there being a bar or a rectangle, there's going to be a point. And notice you can see the points there, the little red dots. And then at the very end, you play connect the dots to make your line. As a mathematician, generally speaking, a line is straight where a curve is not straight. So this one, you can get into a little bit of argument of whether that's a line or a curve. We'll call it a line though, because it's called a line graph. All right, so nothing there that is very different than the bar graph, other than the fact that one is a line and one is a bar. All right, I'm moving on. So we do have notes here. I'll go ahead and show you them all right here so you can copy them down. So first off, instead of putting a bar for each data point, you're going to place a dot, a point, right? Remember last chapter we graphed points. So you're going to graph a point. If everything's positive, remember we're graphing in quadrant 1. Unless we get some negative numbers, you can get some negative numbers. We'll have a couple today. They want to show you that you can have some negative numbers too. But you put a dot instead of a bar. When you're done plotting all your data, then you play connect the dots. Just as in the bar graph, labels are required. Otherwise, the reader will be looking at your graph and not have a clue of what it's about if there's no labels. It's just numbers and a line. And just like the bar graph, the X and the Y axis, although they can have differing units, one can go by 5s and the other ones could go by 1. One can go by 500 and the other one could go by 1 as well too. But the units must be evenly spaced, meaning like if you're looking at just the Y or just the X axis, you need to go up by 2s or up by 5s. You can't in the middle of that switch units from, oh, I went from 5 to start and now I'm going to go by 1s. All right, we okay?
Yep, I got everything down.
Cool. So we're going to start off by making a bar graph. So here's some data. Ooh, notice we have some negative numbers. And let's see. This is the table. So it says the following table gives the average monthly temperatures in Minneapolis, Minnesota. That's way up north, Great Lakes region. Construct a bar graph to illustrate the data. So it looks to me, we have a table, we have 2 columns. So step number 1 is to determine which is your X and which is your Y. Almost universally, the X axis will always be time, and whatever's left is your Y. You've probably heard in science class talking about the independent and dependent variable. Time is almost always your independent variable. Time is almost always your X axis. There's a couple rare occasions when that's not true. But in this case, we're going to make our X axis the time, right? In other words, the months there. If you guys can't realize that, that's January, February, March, April, May. All right, and then the y-axis, we've got negative numbers, so we need something that has both negative and positive numbers. Well, that's fine. That's just going to be quadrant 1 and 4. All right, so let's see how this works. I didn't make the graph, did I? Sorry. So let's make the graph. Well, the first thing you're going to need is, well, you're going to need your X and your Y axis. So try to be neat, right? I'll make my Y axis. It doesn't matter which one you make first. And then I'll make my X axis. And remember, I don't need the big plus symbol. Why? Because some of these are positives and some of these are negative. So I just need the quadrant 1 and quadrant 4. All right. Before I do any labeling, the easiest thing to do is to figure out your y at. Some people do the x-axis first, and that's fine. Well, I already know what the x-axis will be. It'll be the months. It'll be January, February, March, April, May, so forth and so on.
So
this
I
will
have
be.
a question.
Go ahead.
Why did you put the line in the middle?
What do you mean in the middle?
Like the line that's going like vertically, or
Okay.
like going like left and right. Why'd you put it in that spot?
Well, look at the numbers. Are they all positive, or are they a mixture of positive and negative?
Mixture of positive and
that's
negative.
why. So I need space above and below the line to put the positive and negative numbers.
Oh, okay.
Now, like I said, the x-axis is pretty determined. It's going to be January, February. I would hold off. I would always probably, my personal opinion, do the y-axis first. So let's see the y-axis. Well, we got to do something. We got to figure out what's the biggest number and what's the smallest number. So what's the biggest number? What's the biggest number that you see there?
22.2.
Okay, what's the smallest number?
A negative 11.1.
Okay, so here comes, now you got to put on your thinking cap. Somehow I got to go from negative 11 all the way up to positive 22, except it's more than 22 and it's less than 11. So in other words, my top and my bottom tick marks somehow have to be able to include those two numbers. And then secondly, you got to figure out what you want to go by. All right. If I say I want to go by, I don't know, 1, and then I'm starting at negative 11, negative 10, right? That might be negative 10, negative 9, negative 8, negative 7, negative 6. Oh, I don't have enough space. I got to count all the way up to 22 for the positive one. So maybe that's not the way to do it.
You could
The
go
way
by
that-
10s.
Well, if you go by 10, then you're literally probably gonna not have enough tick marks for you to try to guess. There's a happy medium. What I would suggest is to always start with your smallest number, right? Negative 11 is the smallest number, but if I make this negative 11 right here, then my data point is going to be below that. So you want a number that's smaller than even your smallest point. So, and then you also have to be thinking about what do you want to go by. I'm just going to say straight up, if we go by 1s, we're not going to have enough space here. If you go by 10s, we got plenty of space. Negative 10, 0, positive 10, 20, plenty of space there. But then all your data is going to be really crammed together. So, and it'll be hard to graph that as well too. So instead of doing that, maybe instead we go by what? What do you want to go by?
How about 5s?
How about we go by 5? So that would be negative 5. What will be the next tick mark? Halfway between that would be
Negative 10.
no.
Oh, 0.
Well, see my point. Yeah, exactly. So we can't start at negative 5. If that's my bottom one, we need to start at
Negative 10.
yeah, but then we can't fit in negative 11.
Negative 15.
There you go. See how that kind of works? So we got to start with a number that's smaller than the smallest number. So the next number would be
Negative 10.
negative 10, and then the next number would be
Negative 5.
oh, it's looking good. And then the next number would be
0.
that's good. And then
5.
and then
10.
keep talking.
15.
And then I didn't make my
20.
graph tall enough, but I can fix that. And then 20. Except we have to go further. Why?
Because there's a number greater. There's
The
numbers
number greater than
20.
20, and that's 22. So if I make the top one 25, and there you go. Now, absolutely positively, this will take the majority of your time just figuring out what you want to go by and what are the numbers going to be. I did a pretty, I don't know, average job of spacing these out. Notice this one's big space down here between negative 15, negative 10. And then I kind of squeeze 20, 25. So when you do it by hand, right, you can sometimes run into those issues. Try to be as neat as possible. Okay, but the nice thing is that once that's done, the hard part is over. Now we can graph. Now you graph by using bins or by bars. So we're going to make our first bar, and how tall does it have to be for January?
It's a negative 11.1.
So I'm going to go down to negative 11. So negative 11 would be 0.1. Notice I'm doing a little rough estimate right there. And then what? I need a label. So where would my label go? So this is J. Now, if that makes sense, I'm going to make a nice label at the very bottom so that the reader will understand. If you wanted to, you could put JAN for January, no question about it. But my label here in the bottom is going to indicate that those are months. All right, what's my next one?
Negative 8.3.
All right, so I'm going to remember there's space between your bars. So negative 8 would be not all the way up there, but about right there. And keep going.
Then it's negative 2.2.
Negative 2.2 isn't very tall at all. Keep going.
I'm sorry, I'm just getting this down. Then it's 7.2.
Do you want me to stop and you try it yourself from here or what?
I'm just writing it down.
Okay.
Then the next one is 13.9.
And I'm trying to make all of my rectangles the same width and the same spacing between them.
Next is 19.4.
That's almost 20. Okay.
Then it's 22.2.
And that's my tallest one.
Then it's 21.1.
So bigger than 19, but less than 22. There's August. I always find August the hottest month, but apparently not this month, this year. Keep talking. The next one is 15.6.
Wait. Then it's 15.6.
Yep.
Then it's 10.
Yep. I think I'm gonna run out of space here. Gotta extend my bar or my x-axis a little bit. Okay, keep going.
Then X is 0.
Ooh, so I don't need to put anything for 0. You need to leave the space though.
Then it's negative 7.2.
There we go. Oh, now I gotta do a whole bunch of labeling. Maybe I'll label in a different color. Oh, I don't want that. I want a writing tool. All right, so there's my January. There's my February. There's my March, April, May, June. Now notice without a label, these are just letters. So we definitely need to put a label here. August, September, October. Don't forget November, which was 0. So November would be right here. And then December. And we got to label it. So that would be what? Months.
And then the y-axis would be temperature in Celsius.
You can, and notice right here, the table already has the label for us. We just need to write whatever it says. If the table wasn't labeled very accurately, then we had to come up with our own label. And at the very top, we just put the overall title of the graph. So this is average temp. I'm not going to write Minneapolis, Minnesota, but you get the idea. Okay. So how long is that going to take you to do?
5 to 10 minutes, depending
I would agree. So this is not a very quick process. This can take some time. Graph paper certainly makes your life a whole lot easier, but notice I just did it without graph paper and it looks fine. Now, the whole purpose of doing graphs like this is so that we can, I don't know, arrive to some understanding about the data. And it doesn't take a rocket scientist to figure out that, hey, look, in the summertime, it's hot. In the wintertime, it's cold. One interesting thing, that if you do this graph for any location north of the equator, this is what your graph will basically look like. Now, the height of the bars will change. Doesn't get very cold in southern Arizona, even during the winter time, but the shape of the what these bars make, where it starts at the very bottom, goes up, and then drops back down, you get the same shape no matter where you are north of the equator. If you're south of the equator, you get the reverse of this. And remember, their seasons are backwards from ours. So their winter is the hot time, and their summer is the cold time. Kind of crazy when you think about that.
Does that mean Christmas is like hot over there?
In Australia, Christmas is the hottest time of the year.
Wow.
All right. Any question on making a bar graph?
No, I think I got it.
Yep. I don't know. It's kind of fun. All right. Sometimes now it's entirely up to the maker of the graph. Sometimes they'll make their bar graph go sideways. So instead of the x-axis going left to right, the x-axis goes up and down, and the y-axis goes left and right. But notice it's the same darn procedure. Now, why would someone do this? Look at the label there, Ontario, Erie, Michigan. Those are big words. So sometimes instead of writing, because those words would have to be on the bottom there, and either there's not enough space, or it would look cramped, or it would look weird. So notice the way when they put this one horizontally, it just makes the graph a little bit easier to make and also to read as well too. But it's the same darn graph. Will you have to make one sideways? It's entirely, if you want to make your graph tonight for homework sideways, you can. It's entirely up to you. All right, so let's see, make a line graph. So I'm gonna pull back up the graph that we just made. So there's the graph that we just made. In order to turn this into, I'm gonna erase a few things. In order to turn this into a line graph, guess what you have to do? Bea, what do you think you have to do to turn this into a line graph?
Get the first. It's practically the same thing except with the line. Like the line has to go down the point, and then
Right. So the only difference is instead of there being, we draw bars or rectangles. That green didn't really stand out. Maybe brown. As I'm going to put a dot. Instead of making a bar, I'm going to put a dot. Notice where I'm putting the dots. Right. The dots appear right where the top of the bars are at. So we make the dots, and the dots indicate, for instance, I just did July, and July is at 22. So July, J for July, 22, and there's just a dot there at the top. So if there's a dot there at the top, and we have to have one at 0, and I were to erase the bars, right, we would just be left with those dots. So the only difference between a bar graph and a line graph is that instead of making a bar, you make lines. And then the last step, oh, that was horrible, is that, there's your broken line graph right there, is that you connect the dots at the very end. And now maybe you can see why some people like a line graph over a bar graph, because now you're really indicating what's happening with the data. The bars were fine. There's nothing wrong with those. But notice that if we're trying to look at how things are changing, the shape of how things are changing, that line graph really indicates it or shows that. So tonight for homework, we're going to have you make both a bar graph and a line graph, just for practice for that. So it shouldn't be too bad. Like I said, the hardest part about this entire process is the y-axis. The x-axis will be fine, but the y-axis, you might go through a couple iterations of, oh, I'm going to start with, for instance, 0, and I'm going to go by 2s, and all of a sudden you find out you don't have enough space, and then you erase, and okay, now I'll go by 5s. So that process can take some time, and it is more art form than it is science. There's a little bit of math behind it. We get to 8th grade, I'll show you some of that math, but for the most part, you take a big swing at it and see if it works or not. All right. No, I'm not going to have you make a line graph but right now, but you will have to do one for homework. Questions?
Nope.
Should be pretty simple, straightforward. Like I said, the y-axis is the challenging part. Remember, we make graphs to interpret the data, so there will also be questions about a graph. In fact, I think the first couple questions tonight for homework are, they give you a graph and then just simply ask you some things. So I got 4 questions here, and if I look to the right, there's a bar graph. And let's see, it says mountain ranges. Mountain ranges, for instance, we live in the Rocky Mountain Range. Range is just a geographic region of a bunch of mountains, and they all get the same basic. It's like we live on the continent of North America, and North America has 2 main mountain ranges: the Rocky Mountains on the west side of the nation, and the Appalachians on the east side. Let's see. Well, these are mountains inside of ranges. So Mount Vinson, Everest. I can't pronounce that third one, and then Mount McKinley. Mount McKinley has been renamed recently. That's the big tall one in Alaska. It's now called Denali. So it shows you how long ago our book was written. They changed it during the Obama administration, I believe, is when that was changed.
Why did they change the name?
I believe it had something to do with the fact that originally the mountain was called Denali by the Inuit. That's the Native American people that originally lived there. And then eventually we called it Mount McKinley after, of course, McKinley, the president. And he was assassinated, by the way. Um,
Who, who
and then
assassinated him?
eventually it was named back to Denali. There's a car now called the Denali, if I remember right.
Hmm.
All right, so and it's given us an elevation in thousands of feet, and then you got some questions. So go ahead, Vea, read the first one.
Sorry, what was the question again? I spaced out.
Just read the first one.
What data unit is used on the vertical axis?
So they're asking you to look at the vertical axis and look at the units. What are the units in for the vertical axis?
In thousands of feet.
I mean, that's as difficult as it gets right there, right? Not very difficult. All right, I'll do number two. Let's see. Which mountain has the lowest elevation? Well, it's the one that starts with the K. And what's its elevation? So if I read it right, we got to be careful as it says elevation in thousands of feet. So it's just short of 10. So say 9 or something. But that would be in thousands of feet. So it's less than 10,000 feet. Call it, I don't know, 9,000 or something like that. So Mount K, and it's about 9,000 feet. All right, Vea, do the next one.
Which mountain has the highest elevation?
You
What
should
is
know
its
that without a graph. That is,
Mount Everest.
and how tall is Mount Everest?
I want to say around like 26, 27.
Okay, well, look at the graph. Let's see, 25,000 would be right there. Does that look like 26,000?
No, that looks like more like 28, 29.
I agree. I want to say that Mount Everest is 29,000 something feet. But according to our graph, it looks closer to 28, 29, like you said. All right, the last one. Which two mountains have the closest elevation? In other words, they're asking to look at the height of the green bar and which two are closest. Well, clearly Mount Everest and Mount K are way far apart from each other. But Mount Everest and Mount McKinley are kind of close. Let's see, if Everest is 29 or 28 and McKinley looks to be about 21, that's a difference of 7,000 feet. But if you look at McKinley and Vinson, right, that's like 19 and 20. That's only 2,000 apart. So I'm going to go with Vinson and McKinley. I don't think any of the questions tonight for homework are all that challenging. Read them once, read them twice, make sure you understand fully what they're asking, and then read the graph carefully. All right. Any questions on interpreting bar graphs?
No.
Well, if we interpret bar graph, we're probably also going to.
Maybe.
If we're interpreting a bar graph, we're probably also going to be asked
A line
to.
graph.
Yeah, do the same thing for the line graph. So you got all four of these this time.
Yeah, I don't have these questions on my sheet, but that's okay.
You do. It's on your sheet. I mean, you have the graph. You don't have the questions.
Yeah, that's what I was saying.
Go ahead. Do question one.
Okay. What data unit is used on the vertical axis? That's like millions of peoples.
Yeah, millions of people. All right, number two.
What was the approximated population in 1900? Around 60 million.
Let's see, 1900. We have to read up to it and read across, and halfway between 50 and 100 would be. I'm going to go with what you said was 60. It's probably closer to 75 though, because it looks to be about halfway between 50 and 100, right? How about 1950?
In 1950, it was.
That was a little bit hard. First, you got to find 1950, and then read straight up.
It's 150.
And then straight across. Yeah, it's 150. Yeah, that's right. All right, number three.
What year did it get past 100 million? That would be
100 million is right here.
1940.
So here's 100 million. So when did it get past 100 million?
1930.
Well, 30 would be right here.
That's past it.
Well, yeah, but so when did it first pass 100 million?
1930.
Yeah, okay, I'm going to erase everything. Where is 1930? So 1930 is halfway between 20 and 40, right?
Yeah.
So if you look straight up from 1930, you are already past 100 million. So when did you, that's a horrible line, but you get the idea. When did it pass 100 million? What year did it get past 100 million? Right there, I'm about, I don't know, 115, 120 million right there by 1930. When did I first go over 100 million?
1940.
Where is 100 million on the graph?
Right.
I'm doing blue. We go straight across. Why is this not drawing?
Oh, 19.
We go straight across. There's 100 million. Where does the red line intersect 100 million?
Oh, it's around like 1920s.
Yeah. So 1920 looks to be a little bit less than 100 million, right? So I mean, I can't tell for sure, 100% accuracy, but I'd say it's close to 1921, right? It's certainly not 1930 because we're way above 100 million at 1930. It's also not 1920 because you can see the red dot. The red dot is underneath the 100 million line at 1920. So, I mean, if you would have guessed 1922, I probably would have said, okay, sounds about right. I'm going to go with 21. All right, when did you pass 200 million?
1961.
Okay, so let's find 1961. Where is 1961? 1961 would be right here.
Oh.
You see where I'm getting that from?
Yeah.
Okay.
It would be 1970.
Yeah, that's what I would probably go with, 1970. All right, so 1970. The book said 75, but I'm okay with 70. That's definitely close to the right answer. All right, keep going. Last questions.
What was the total population increased in the 20th century?
Ooh, that's a hard question. What is the 20th century?
That is the 2000. No, that's the 1900s.
1900s, all of them. Hey, guess what our graph shows?
Millions of people.
No, the time. What is the time in our graph?
Decades.
Of the what?
19th century, 20th century.
There you go. So that basically, it wants you to read the graph and say how much did our population increase during the 1900s. Well, how are we going to do that?
Look at the last decade and in the 20th century, which would be the 1990s.
Well, what did we end up with at the very end?
We end up with around 250 million.
Okay, so it says, what's the top population increased for the 20th century? So how are we going to figure that? We know what we end with. We end with 250. How do you figure out an increase?
Well, that means addition. So you subtract.
Subtract what from what?
I'm not sure.
Well, if I ask you how much did you grow this year, how would you figure that out?
I would look like all the measurements I had during my height, and then I would take my current height from my least current height, and
okay, it's the same question.
Oh, okay. So you subtract the 250 million from around.
Other way around.
You subtract 75 million.
Yeah.
From
so the starting from the concluding. So subtract from 250 million, if we agree that 75, and that would be 175 million. So our population increased by 175. That's crazy, right? Our population increased to 175 million during the 20th century. All right, those are just like what your questions will look like tonight for homework. And that was the whole darn class. So let's see, we did a bar graph, we did a line graph, and then we did questions on both bar graphs and line graphs. It will take you some time to make the graphs. It will also take you some time when you're making the graphs to figure out your y-axis. That's the one you got to spend the most attention to detail. Remember how we did it? We looked at the largest number, we looked at the smallest number. If the numbers are all positive, then obviously you're starting with 0. But if you have a mixture of positive and negative numbers, well, then you have to take that into account. And then figure out how much you go up by is the second hardest thing to figure out. So usually it's by 1s or by 2s or 5s or 10s or 100s or 1,000, something like that. All right. I also want to point out the last thing you'll have in question number 10, they'll ask you to make a line graph, except they say a broken line graph. That's just a line graph. All right. Any questions on anything we did?
No, I don't have any questions.
Cool. Well, that's it. Hey, just remember, for those of you that I called off your names at the beginning, you have to have your test done. If you're watching this video and because you're a day behind, and that's fine, remember you'd be watching this video on a Wednesday. Your grade is already 0 because on Tuesday, physically when I'm making this video, you should have been taking your test. So I will put the zeros in the grade books tonight meaning my Tuesday. So that when you get that next video, make sure you take your test. I guess that's the message I'm trying to tell you. All right, I'm going to close it right there. You guys have a wonderful day, and we will see you tomorrow. Oh, I'm sorry. You will not see me tomorrow because I'm doing the PSAT test. So there will be a worksheet. It won't be long. I'll just be making a bar graph or a line graph, that sort of thing, on the online. So you'll see an assignment. It'll just say review assignment. Just do that one assignment, and then we'll meet back together on Thursday. See you guys.
See you.